The first experiment that you're going to do in the organic lab this semester is the taking of a melting point of two pure materials and the various mixtures of them. And the device that we're going to use is what we call the melt temp. Now we have two varieties of this melt temp in the lab. This is the older of two varieties, but it performs this very same function both. So we're going to be using that. And I decided that for this demonstration that I'm going to use transenamic acid, which comes in a large container like this. We're certainly not going to use all of this, but we're going to take a little bit and put it on a watch glass here. I like transenamic acid because it's nice and dry, and it's nice and crystalline, and it's within the range of our equipment. Now, there, so we've got this much on a watch glass. Okay, that would suffice for 25 melting points at the amounts that we use. Okay, so that's the first thing. We have the transenamic acid. The second thing that we have to provide is a thermometer. Now these thermometers are going to fit in what we call these thermometer wells. Now the melt temp, I should point out, is a variac which then heats this aluminum bar, and we have a light. You can see the light go on and off here. That's going to illuminate the sample chamber, which is right over here. And we can look through a magnifying glass right on top here that magnifies the bottom of the melting point tube, and there you can tell whether the sample is melting or not. But it's important that you get the right thermometer. Now the thermometer that I have has a range of between -20 and +150. Obviously we don't want to go outside the range of the compounds that we're looking at the melting point of. In fact, this one goes up to 150. The transenamic acid is going to melt at about 133. So we're within the range. Now, I always caution students that before they begin any type of melting point determination, they check to see that their thermometer fits into this little breech right here. If it doesn't, if there's any amount of stoppage from going all the way in, then abandon trying to push it in any further, because we have found that we can't get these thermometers out without breaking them once they are jammed in this tube right here. So this seems to fit okay. I'm just going to put my thermometer in there, like that. Okay. And now we have to fill up a melting point tube, which we will find in various places around the lab. This has 100 little melting point capillaries. I'll take one out, and all these capillaries are just very thin glass tubes, okay, which have a sealed end in it. I've got this turned upside down, the sealed end up, because I want to take the capillary and I want to push it down into the solid that I have on the watch glass here. And I push it in several times, and I can get about, maybe I've got 3-4 millimeters column of solid in here. Now, how do I get that from here down to where it should be, at the closed end? Well, the easiest way, if your sample is dry, is to just simply tap the closed end onto the desktop, and it should pack it down. It's about 4 millimeters right there. You can't see that, but it is. And now, we're going to put the sample in this sample holder right here. And Meltemp has provided 3 such positions in this sample holder, which means that you can take up to 3 melting points at one time. Now, how do you know how to set the variac here? Well, there is a graph that's provided in your online lab manual, which I have a copy here. Okay, and it is time versus temperature. Now actually, what you're most interested in is how high the aluminum block gets with each setting that you have on the Variac. Now if I were to set this to 20 volts, what I can expect then after about 30 minutes is the temperature leveling off at about 78 degrees centigrade. Obviously, if I put a higher voltage, let's say 40 here, I follow this line, I can get up to 141. Okay. It's 141 there in about 30 minutes. But I know all of you are impatient, so if you were to set it higher, then it would go up to, let's say you set it at 60 volts. Well, it would go up to 228 in a space of about 25 minutes, and it would certainly pass 135 in, let's see, 135 is right about here, in about 10 minutes. So you could actually take the melting point of this sample and get out of lab on time. I've got the sample in the sample holder, and I turn the thing on. And it's now at 20 degrees, but eventually it's going to get up to, according to my chart, it's going to get up to 101 in 30 minutes. Now this demo is not going to last that long, obviously, but what will happen is then the aluminum block will be heated. It's already starting to feel a little bit warm, and eventually it's going to get hot. Hot so that you can't just put your hand on it. You could get burned. In fact, you got to watch yourself with these. If I want to set this up higher, I could do that. If I want to set it lower, I could do that. But I got to set up at least to the voltage that will give me a reasonable rise in temperature and get up to over 135 degrees. So that's what I've done right here. And now it's just a matter of waiting. Now, how do you know when a sample melts? Well, it's really very simple. You watch through the magnifying lens, okay, right here. Watch through the magnifying lens, and you're going to notice that the sample, when it nears the melting point, it will start to soften and sort of contract. That's very easy to see. When the sample is completely melted, that would be called the melting point. Now, it's usually just for a pure sample, a couple of degrees between when the sample begins to melt and when it finally melts. And those are the two temperatures that we report. That's called a melting point range. Now, a melting point is a misnomer, obviously, okay, because we're not going to report just one temperature. We're going to report two temperatures, the bottom and the top of that, what we call melting range. Okay? So the only way to learn this technique is to do it, and you will be very surprised at how adept you get at this, because we do this a lot in the identification of the molecules that we work with. Now, a couple of things to remember. We don't clean these, all right? I've had students try to scrape out the solid in there. What we do with these is put these in a throwaway glass receptacle. So we just throw that away. The second thing is that we allow this aluminum block, which is now quite hot to the touch, we allow this aluminum block to cool down, okay, for several minutes. And when we unplug the melt temp, we don't take this cord and wrap it around, because a lot of times the cord touches this very hot aluminum block, and in fact it will melt the insulation off of the cord here. Now you can see that there is some deterioration here, which does not present any sort of a problem, but which in fact should not have to be if you are vigilant and let these things cool down. And they cool down reasonably fast, and then put them away, trying not to wrap the cord around it. Okay, so that's what you're going to be doing first experiment this semester, and I think that you're going to have a good time determining the melting point of materials that we give to you.